dxctl was released with Portal starting in CF19. This CLI allows you to deploy, update, and remove Portal deployments. It also allows you to collect diagnostic data when troubleshooting issues. In this video, I will show you how to use dxctl to deploy Portal, Digital Asset Management, and Content Composer on Red Hat OpenShift. For the product documentation, I can deploy Portal using the deploy flag and passing in the corresponding properties file. I can see the other flags available are update, collect, and destroy. When you download CF19 container zip, you will find a zip named HCL DX Cloud Scripts. Within this zip file, you can see it contains a deploy, dxctl, and scripts directory. The dxctl/properties directory has a sample properties file for creating a full deployment. As you can see, I have this properties file open in my editor, which contains some sample values. I have created a copy of this properties files and have already filled in the actual values for my deployment, which I will walk through now. For this video, I'm using the latest Portal release, which at the time is CF191. So for the name of my namespace or project, I chose to use dx-191. hub.dx.com is my image repository where I pushed all the CF191 images. I'll also use dx191 for the name of the core pods. Core and v95_191 are the image name and tags for the core Portal image I used. If I jump over to my image repository, you can see the names and tags I have chosen for all of the CF191 images. Moving on in the properties file, the next item of concern is the name of the storage class. I have already created the storage class for the product documentation on my OpenShift cluster, so I can verify the name under the storage classes on the web console. Similarly, I have already created the WP profile and the digital asset management persistent volumes, so I can grab their names from the web console under persistent volumes. Please note that I have a couple of generic self-provisioning persistent volumes available. I will need a self-provisioning persistent volume for each of the digital asset management persistent pods. I'll keep Derby as my database type until I've performed a database transfer. I'll leave the logging, pod policy, and readiness pro options as a default, but these can be customized as needed. On the exposed routes, I have updated the configuration wizard to true, so I can use it later to perform my database transfer. I'll leave the resource options as default, but again, these can be customized as needed. The dx.config.authoring is set to true, so this deployment will be configured as an authoring environment. If this was a rendering environment, I can set this to false and the rendering caches will automatically be enabled. I will not deploy remote search nor open LDEP at this time, so I'll set those to false. Obviously, this isn't a hybrid deployment, so that will stay false. Next, I need to enable the Experience API since I'm deploying Digital Asset Management and Content Composer. So I'll set that to true and enter the Experience API image name and tag. For all of these pods, I'm setting the min and max replicas to 1 since this is a test environment, but these values can be adjusted as needed. Next, I'm enabling Content Composer and entering the image name and tag. For Digital Asset Management, I will need to enable it as well, but in addition to the image name and tag, I also need to enter my persistent volume and storage class. As we saw earlier, I have already created the persistent volume, and I'm going to use the same storage class as I used for my WP profile persistent volume. I also need to enter the Digital Asset Management persistent image name and tag. Again, for all of these features, the resources can be adjusted as needed, but I'm leaving them all as default except for the min and the max replicas. Digital Asset Management also requires the image processor, so I need to enter its image name and tag as well. Since this is OpenShift, which uses routes, I can ignore the ingress options. Next, I need to enter the operators. First, the cloud operator image name and tag. The cloud operator also allows you to specify a name, so I've provided a name. And finally, I need to enter the digital asset management operator image name and tag. This completes all the required options needed for my deployment. Moving over to my terminal, you need to have kubeconfig set up to access your cluster prior to running dxctl. As you can see, I can use the OC CLI successfully on this machine. So within the dxctl directory, I'll run the dxctl with the deploy option and point to my modified properties file. Everything looks good until we get that fatal error at the end of the output. So I did this intentionally to demonstrate that as of CF191, dxctl does not create the dxdeployment custom resource definition. In order to create any ported deployments, I first need to create this. And since the scripts are still provided, which is how we deployed Portal prior to CF19, I can run the deploy crd shell script, which will create the dxdeployment definition. With that created, I'll run dxctl again. I see some non-fatal errors because some of the resources already exist from the last run, but at the bottom, this time we can see the deployment was created. And if I jump over to my OpenShift web console, I can see, well, first that the persistent volumes for the WP profile, digital asset management, and the digital asset management persistent pods are all bound already. But if I go over to projects, I can see my DX-191 project has been created. And if I navigate under pods, I can see all the pods have already been created. After the core pod is fully initialized, it will be running, and I can verify I can access Portal using the appropriate route.